So our next speaker is Johan Helin. Johan is a senior IT security engineer with a strong background in network technologies and software development. He has 30 years experience in information technology, spending the last 20 years in IT security in various domains, such as car, automotive, manufacturing, financial, and now space engineering. Johan was a senior project leader in several successful corporate projects related to IT security, such as system hardening, business continuity, and vulnerability management. And Johan also holds several certificates in IT, but also in pedagogical aptitude. Oh, that's nice. Okay. Thank you. So welcome, Johan.
Thank you, Emma, for the introduction. Yeah, indeed. In the coming minutes, I will show you on how we can use a cyber range called CYSAT in order to not only make some tests against satellite and communication, again, voila, but also to see on how we can train user, how we can train people who will work on satellite stuff and space environment. Yeah. So CYSAT, it's mainly a product that RHEA has built. The main goal is regarding the training, the research development, and also the testing and evaluation. So the training is a very important aspect. Here today and yesterday we spoke a lot about how to hack a satellite and stuff like that. But here we will focus on the training, on how we can train people who work on as a space engineer, someone who have to design something related to space, but also some SOC operator, for example, who have to monitor some event on the space or the ground segment. It's also interesting also for research and development. With CYSAT, you can work on some malicious software, malware, ransomware, and therefore you can also make some forensic and reverse engineering capabilities in order to better understand on how it's going and what will be the impact on the infrastructure. CYSAT is also a tool that you can test and evaluate some procedure. For example, in case of disaster recovery, we can simulate, if you want, or we can replicate a digital twin of 2 data centers. We could imagine to stop one and check if the procedure to fail over to the second data center, could be automatic or manually done, it's well done, if the procedure is okay, and how to evaluate the reaction of the people who have to work on that. As you can imagine, when you have a disaster recovery procedure triggered, a lot of people are in a panic mode, and by doing some drill exercise, you can decrease the stress level and also to foresee and to see what will be the next action, and you can also evaluate the time that it will take to recover to the normal situation. So, CYSAT, here, regarding the training part, you have here an illustration of the training room that we are using in RHEA, so in Belgium, in the ESA station. It's a room equipped with 22 computers, so that means we can offer some trainings to multiple students at the same time in order to put them in a very immersive world to get them trained on the cyber attack things or at basic awareness level, but also in red and blue team exercise for more advanced user. Yeah, so I will now jump to a real demonstration. Voila. So after you log, after you are logged in the CYSAT system, depending your permission, you can do more or less activities. You have a lot of scenario already existing, but you can also create your own from scratch. Here, for the purpose of the demonstration, I will show you here an exercise that I've prepared, where we can see a satellite, and we will see what I mean by satellite, antenna, an attacker somewhere, but also maybe here a mission control system running in various operating systems. And we have also here a hybrid network. I will touch a word regarding that because it's a very, very interesting feature of CYSAT. So how it works, very quickly, it's a drag and drop system that you can click on the icon, and from there you can choose what type of asset that you want. Okay, here, for example, it's a Windows or something. So you choose within the library here, Yeah, we can see for the moment, okay, we have 24 different versions of Windows system. You can see here, it's Windows or Windows with some additional element. The idea is to have some generic image in order to deploy on many and various different scenarios. However, when we want to customize or to finalize the setting of one machine that you will deploy later, we are using here, as you can see, Ansible, which is an automation scripting tool, I would say, in order to push the latest settings. For example, I could imagine that each time I use a Windows machine, that when the machine is ready, I push, for example, a background, or I change the color in order to be more realistic or to be very close from the environment that we want to emulate. For the server, of course, it's the same, except that, of course, the list of assets that we propose here are related to server environment. It could be Windows and Linux again. So there are various different flavors of Windows or Linux or whatever you want. We have more than 180 different machines already there. But again, when I deploy a server, for example, for which I need a web server, a mail server, or any kind of other services, I can do it there, and after I can instruct Ansible to push my website, to push my application, to push whatever I want on the system in order to make it reusable all the time. Another interesting feature of CYSAT, it's when everything has been designed, and you will see it in action after, you can also define here on the top some schedule, some action that you schedule maybe after 30 minutes, after 20 minutes, and so on. So depending on the action that you put there, it could interfere with some Windows machine, Linux machine, or the satellite that you will emulate. It's very interesting when you make some exercise that you can put the people in an exercise, and you know in advance that maybe in 10 minutes something will happen. An attack, for example, or network discovery, or any kind of other event that are not usual, and you can observe the reaction of the people, if they are using the appropriate procedure, if they are using the appropriate command to stop it or to isolate, and so on. Another feature is also here I can just define some application here, action, sorry, and could imagine, for example, here it's something to to simulate, I don't know, camera. So that means when I will start my scenario, when all the machine will be ready, and anytime someone, an operator, could click on that button, and behind that button you can here choose the action that it will happen. Most of the time it's a script that will trigger something on a specific asset. And therefore you can again also observe how the system will react, and how people also will react on the event that they just saw. To go back here, CYSAT is very useful for cyber attack training for the, let's say, highest level of the OSI model. However, for application level and so on. However, regarding the physical layer of the network, here you can see, I will move this, voila. You can see there is a hybrid icon, an hybrid object. So simply by adding the hybrid network on my scenario, it will instruct to CTF that somewhere we will have a physical asset that I will be able to connect on my virtual world. So that means with a RJ45 cable, USB cable, or any kind of other connection, the physical asset, everything behind that in the real world, will be seen in the virtual environment. So it's very useful when you want to, for example, work with a flat satellite that you, or other open source project to emulate satellite. You can have the physical part somewhere with that magic cable, I will say. It's seen on your environment. CYSAT proposes also to list some questions to evaluate the skills, but also some questionnaire. It could be a checklist when you have to train people, and you can always define a score, and it could be integrated with your learning management system and many other learning management tool existing on the market. So it's also a very interesting thing, because you can associate some document there, and the document will be triggered when you click something on when there is a special event happening. So camera failure event, for example, you click on there, and boom, the person will be able to see maybe the procedure to follow or additional instruction to read as a PDF file or whatever you want. So when we have all these icon or object defined, you can really access them. Here you can see it's just some button, but when you click on a button somewhere, it will really instantiate, it will really push in production, I would say, the environment. I have another scenario who is already who is already prepared to save time here. Voilà. When the scenario is running, you can see there is a blue icon on the top. It's to access it. So if I take the example here, I'm not authorized to show you some real satellite disk image that we have already in CTF for confidentiality reason. So here I just make a very basic representation to have something also to demonstrate the capabilities of CTF. So here I have to log on my machine. Voila, we do it like this to have a bigger screen. Voila, okay. Control C. So here it's a Linux machine, by the way, running a Python script to just simulate a satellite flying in orbit, but it's also to demonstrate that the system can support 3D stuff and graphical things. Okay, here I apologize with the delay is because of the VPN connection that it make a small let's say delay like this. But okay, let's imagine that I have something flying somewhere. It generates some coordinate here. Okay, it's running in Windows. Okay, that's in Linux. That's good. Here I have maybe another machine here acting as a mission control system. Well, it's coming. It's an illustration to see that the system can support, can support Windows, but also PowerShell and very modern scripting language. So if I start it, I will put it in a large screen. I can do it like this. Voila. If I start it there. Okay, so my PowerShell script run, and okay, here you read the data coming from that machine. So because everything is interconnected, so it's just a basic example. I know that it's not realistic for satellite on how it works, but it's just to demonstrate the potential of CyTF. To go back on more realistic things, I have, however, some slide that I can show you with a real product that we are using. Here, this is for a project really that we just start to work on that, and just to show a more realistic mission control system that we are using. So everything is supported. As soon as you have the image, the disk image, that we can virtualize, we can insert it in CTF, and after you can reuse as much as you want. Here there is another example of scenario. It's been done for Traleo. Maybe 2 years ago now, and it was just to demonstrate that we were able to sniff some information. So that image here is really an image from a satellite that we receive from our client. So there are some things that we can do a realistic way, and there are some other things that, okay, we have to make some imagination. For example, in the scenario that you want to create, the only limit that we see for the moment is let's say the imagination of the people who have to create a scenario to find some very interesting, very innovative attacks or use case in order to evaluate the reaction, the behavior, and also the procedure that people have to use in such condition. We can have very, very elaborated scenario, not only on the space, we have also the maritime, the energy sector, and also the water distribution sector with some very, very complex scenario that we can reproduce. There is something interesting that I forgot to mention here on the demonstration. It's, where it is? Voilà. When you create, oops. When you create a machine, in order to make it simple, if you have, for example, 5 operator machine running to monitor some satellite data, instead of to create 10 times the machine here, you can also simply you can here simply say, okay, that machine will be created 5 times. Okay, and the system will manage the IPs and will manage everything. There is something very interesting here. You see the CPU. This is the physical CPU that you will reserve for that machine. Here, CYSAT proposed to have a fraction of CPU. Could be 0.5, 0.8, and something similar. It looks like a detail, but it's very important. When you have a scenario, for example, this one, 1, 2, 3, 4, 5, 6, there are 6 machines. So that means we will deploy 6 virtual machines. If you have 10 students participating to a training, they will have their own scenario, totally isolated. Therefore, that means you will have 60 CPU. And if you have also, if you choose, for example, 2 CPU here, so that means it could be 120 CPU just to run the scenario. So by, let's say, fine-tuning the CPU, you can also leverage your infrastructure, of course. The multiplicity, okay, it's a nice thing. And regarding the network here, okay, well, okay. You have to know that we are creating almost all the scenario without internet connection in order to ensure the full isolation. So that means everything is managed through those 2 machines below. They are not visible to the trainer. It's only the scenario creator who can manage that machine to push some instruction on all these machines. It's a very interesting feature. This is the only way to make, let's say, visible this from your laptop, from your workstation when you have to create the scenario. But as soon as the scenario is instantiated, these disappear and the scenario is totally isolated. It's really, really important, especially when you are working on malware and ransomware. Voilà. So here, voilà, if I go back on this one, scenario, yes. Voilà, refresh. Voilà. Last word regarding the manager, the user and the visibility. Okay, when you have come on, diagram here. We could imagine that the attacker here can see only the antenna, for example, and he will not see all other machines. We could imagine that an operator working here can access only that machine, but he can see this one, and this one. So you can play with the privilege of each user, depending their role, because otherwise it will be too easy for the attacker to see the network if he can see on the map. Here you have to use some instruction to recognize the network like nmap and stuff like that. And after that, okay, try to find the vulnerabilities. You know, the classical path when you have to perform some attacks. So you can play with the visibility and the access for each user as well. And also on the live, the teacher or the people who are there can always see what each student is doing in order to help him or to give some guidance to say, okay, you should do this, and so on. And a last word regarding that, it's CTF also can be used so to test and to validate, but also to pass some certification. Instead of to do it on a test environment composed of only physical assets, you can execute everything also in that virtual world, which is a little bit easier, I will say, because you can do a redo and redo on demand. But voilà, this is conclude my live demonstration of CTEF. Here, voilà. Oui. Voilà. Okay, here there are some other scenarios running for other type of exercise, but it will be too long to have a look on all of them. Thank you for your attention.
Thank you very much, Johan, for the very nice presentation and demo. So we have some questions. So the first question comes from Cesar Carmona, and he's saying, do you have libraries available for space-specific network equipment like Cortex modem, Kongsberg, etc.?
I expected this kind of question, and I'm not a space engineer. But based on my colleague, yes, we have some specific assets for network, for space-specific networks. We have also developed our internal tool, I think it's called SST, Space Security Tool, to generate some, let's say, telecommunication data coming from a satellite, and you can also fake them or interfere on them. But to be honest, on that very specific space aspect, I cannot answer. But I know that there are some specific space libraries that we can use, indeed. Yeah.
Okay, thank you. The next question. So it's a question from Brendan Bailey. Does the range have the capability to do automated red team action across the range, like execute TTPS? If so, what platform do you use for TTPS? So for the automated red team action, yes, we can do it. But now, like tactic and TTP here, so on, no, I cannot answer to that question, because again, here, if we are talking about very specific space, tactic and technique and procedure, yeah, I'm not comfortable enough on that aspect. But for classical red team exercise, yes, we can automate some red team exercise to trigger some action on specific event or in specific time frame and things like that. Yes, it works. Okay, thank you. Thank you, Brandon. Yes, please.
Hi. Did I see it correctly that you rely on Ansible to, well, basically what you do on the user graphical interface, you translate it into filing within Ansible to, you know, configure the network, etc., etc. Is that
absolutely?
So?
Yeah. So we have a set of playbook to do some classic stuff, you know, change the resolution, and we have a long list library of existing playbook. But again, for very specific scenario, we design the playbook based on what the client wants or what we want to create as a situation. For example, sometimes we want to create a vulnerable machine, especially on the CVE number 123. So we are loading, let's say, a Windows version, and sometimes we are obliged to remove some patch in order to make the machine vulnerable. So it's done also through Ansible. We have an exercise where we have also a full Active Directory that we promote it, and we create a domain. We insert 1,000 users in the scenario, and some client has to have their real username that they give us before. So in order to make it very, very, very realistic, indeed, yeah. It's done through Ansible, yeah.
And do you use images of certain machines, and you have the Ansible agent on top to do the configuration, or you do it from scratch?
Yeah. No. When we create an asset on the asset library, there is always what we call the contextualization is to add some Ansible stuff in order to make it possible with Ansible, but it's the basic settings at the end. And yeah, it's part of the construction of the bricks. This is the term that we use. It is not so difficult to do as soon as you know on how to follow the step, and after that it's quite practicable, yeah, indeed.
Yep, thanks a lot.
Thank you.
Yes.
Hi. How many space scenarios have you designed so far, and how hard is to maintain them? Because they are all IT infrastructure, so they need some maintenance.
I don't know how many scenarios we have already designed, but I know that we have several, and I cannot tell how much, several satellite image in our library. And most of the time, each satellite image is for one specific scenario. So we have, let's say, between 10 and 20, I would say, yeah, because at the end it's always the same, I should say, except the satellite image also is really unique by definition, but the what we want to test and to check, it's not always the same, but it's always the same concept. So we can reuse a lot of things. There is also an asset library where we can reuse some portion of existing scenario instead of we start always from scratch. We can import it and so on. There is another feature which is also interesting, is the federation of the cyber range. If there are two companies or two sub-companies having the cyber range, they can work together to share the resources and to share the scenario of one to the other and to make it visible and so on. Yeah.
And the second question was, how are these to maintain those architectures, topologies, name it, infrastructures?
Now, within RHEA, we have a team who is in charge to create the scenario, but also to maintain them. That team also is very responsive. For example, if there is a new vulnerability discovered, they immediately create a scenario, a basic one, to reflect that vulnerabilities, to make it available for people. You know, there are some universities, for example, who connect to the server range, and they can use it to better understand what mean that vulnerability and how to use it, and also how to protect it. So there is a team of 5 people working on that to create the training, to create the content, but also to maintain the existing scenarios.
Thank you.
Okay. Thank you, everyone. Thank you, Johan.
Thank you for your attention. Thank you.